Yeah, and without further ado, let me hand the stage to Dominik Schmid from Polygon Miden.
Thank you very much. Nice. Thank you very much. I see a lot of familiar faces, which is nice. Hello to the Lambda guys. And can I? Yeah. So I will moderate the first session, and I will always introduce the speakers. And I just want to briefly set the stage about the problem of scalability in this decentralized infra event. And the question is always, can we have the cake and eat it too? And probably you all know the problem of scalability, but I just want to lay out first the basic goals. So what do we actually mean, or what do we want to reach when we mean we want to scale our infrastructure to meet certain goals, and what do we mean by that? And I would say, like, what we want eventually is to, in some sort, replace cash and maybe even traditional stock exchanges. So we can use that as a basic ground. And does any one of you know how many TPS we would need to replace cash? Like, how many transactions per second does cash have worldwide? 1 million? Yeah? Yeah, like it's very hard to track because we don't really track cash transactions, but it's around 20,000 to 100,000 TPS. And so if we really would want to replace that, we need infrastructure that can support that. And for stock exchanges, it's even more, way more. And the other problem is also latency, which our infrastructure somehow needs to support, right? So for cash, it would be okay to wait for 1 second or so. Like Visa accepts, I think, 400 milliseconds. But stock exchanges, like, they are super fast, and we need to be super fast in a decentralized infrastructure. But to say some numbers, so let's say we want to reach to 10,000, like 10 billion accounts that would interact somehow on our infrastructure. We need these 100,000 TPS, at least for now. And actually, we want non-trivial transactions as well, right? So we want to do more than just cash, and maybe more than just transferring assets. We want somehow to let the vision come alive of programmable money and maybe even super complex DeFi transactions. And yeah, the question is this possible? But I will just skip that to the problem. And actually, the problem of scalability, like it is discussed in length since 10 years or even longer, but it's very hard to find a formal definition of the problem of scalability. So I take a definition from Vitalik from 2017, which to me makes a lot of sense. But actually, we can define OFC as like the transactions per second that a normal node can process, right? And then we can say, like in a naive implementation, the network capacity would be bound by the slowest node. If you want, like, the average Joe to participate in the network, then we would be bound by these OFC. So in that sense, we can define decentralization as OFC hardware, the average Joe's laptop, can verify the network. This is our goal in decentralization. In scalability, we would say somehow we want O of n, which is bigger than OFC transactions per second. And that would mean somehow we need to scale more than just linear in that case, like, which is already, you see, a tension there. And then we have the security property, so we need to be able to secure the network against attackers with some fraction of the total amount of economic activity in the network. And in that sense, like, we can say it should be O of n resources, but we can set this value, basically, what level of security we want. And then there are different approaches on scalability, and at the moment I just focus on TPS, but obviously it's also latency, and I just want to explain those or refresh those because we have speakers today. They have very nice solutions that fit in some of these buckets, or some even like tick more than just one box. But if we want to like to make a structure of this, to get more TPS, we could do it on-chain, and that, or off-chain, right? So we could have off-chain scaling solutions or on-chain scaling solutions. And on the on-chain part, we could just increase the node requirements. That would be easy. We can just say like all our nodes now need to be better, and we can even do that with the average Joe's laptop if we just keep pace with how the hardware innovation speed is. Or we can say we keep the node requirements, and we want to stay decentralized in that sense. When we keep the node requirements, or when we increase the node requirements, we have the problem that normally the average Joe cannot participate anymore. And when we keep the node requirements, we could optimize on execution. And this is like there are various different approaches, and we will hear some of them today. But like just a hint, it could be we could somehow parallelize execution and go away from this sequential execution that Ethereum has, for example. And we will see how Solana is doing it. We could also optimize the state. We could chart the state. We can have way more efficient state management. We will hear today a talk about DRAM as well, like decentralized random access memory, which is super interesting, how you can access the state way quicker. And like this is not a problem right now, but in the future we will also need to think about bandwidth optimizations, because at some point we need to send around these 100,000 transactions per second. And if these transactions are 300 kilobytes or so, then we need to think, how can we build a network that can also send these data packages around. On the off-chain scaling solutions, it's a completely viable solution to just use a SAX or PayPal that also scales, but it again excludes the average Joe because he cannot verify what PayPal is doing. Or we can stay non-custodial, and now we are coming into Ethereum's vision of scaling, right? So we have non-custodial off-chain scaling solutions that could be a roll-up. But in the beginning, we also said that sidechains will scale our network, so we can just add Bitcoin Cash and Bitcoin Diamond and whatever, and that will eventually scale Bitcoin. There was even a famous paper, 2016, Is My Sofa a Sidechain? I don't know if you remember that, but it's, like what a sidechain is actually not quite clear. But it will, sidechains, they have the problem that they are not very secure against these attackers. Basically, you just divide by the number of sidechains you have your security property. And a very smart off-chain non-custodial scaling solutions are layer 2s that starts with Lightning Network or Raiden, but going up to super sophisticated CK rollups or optimistic rollups. But their common denominator is that they all have a proof. So somehow they move state and execution off-chain or off the layer 1, but they still prove that the state transitions are correct. And today we will hear about various solutions in these fields, and some of them even, as I said, like tick boxes in many categories. And yeah, really looking forward to hearing the first talk. So, yeah, like the first talk is Shrek. I hope I pronounce it correctly. He's building the pod network. And they scale so well because they remove consensus, which I'm really interested to hear about.